need to clear up a point about the integral test, and maybe it's a little bit subtle, something we got to think about a little bit more carefully. So let me just draw up two pictures, and this really harkens back to kind of an upper and a lower sum in Riemann sums. Let's imagine we got the same function in both cases. Doesn't matter. I'm just going to tell you right off that it qualifies. In other words, it's continuous, positive, and decreasing. And they don't look the same, but they are the same, okay? And so here's 1, 2, 3, 4. 1, 2, 3, 4, like that. So let me just draw up our little rectangles again. And this one looks like that. And then this one like this. And then the next one like that. And if we were to integrate this function, whatever it is, this function of x dx, and we were going to integrate it from 1 to infinity, you could see that these rectangles, if we went dot, 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 and went all the way out to infinity, these rectangles actually have an area that is larger than the area under the curve, right? On the other hand, if we had drawn it a little differently, so this is, let me just write in here, literally, this is A1, the first element of our series, A sub 2, the second element, A sub 3, the third element. Let's now draw this picture just a little bit differently. Let's draw it this way. This is this. It's the same value. I'm just replotting it over here instead of here, so we get A1. And then now A2. It's exactly the same rectangle as this. I've just repositioned where it is. So now we're getting kind of the lower Riemann sum. Dot, 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 on to infinity. And now you can see that, and let's just concentrate after 1, okay? Now this integral, the solution to this definite integral, is going to be a bit more than the sum. So the thing to remember here is that this integral is larger than the sum of A2 plus A3 plus A4 dot, dot, dot to infinity. But right now, the integral, which starts from here and goes forward, does not have anything to say about A1. So what we did was we said when we made our integral from x equals 1 to infinity of f of x dx, we said, well, let's just add A1 to it, whatever value that is. Let's just add that in, and then this whole thing will definitely be larger than the sum from, I don't know, n equals 1 to infinity of a sub n, right? Because I've added this bit in now, artificially, not via calculus, just stuck it in over here. And now that we've added that bit in, that's obviously the same size as A1 is the same size as the first element over here. And then all the rest of the elements are somewhat smaller because of this little difference here. So we know that this is greater than that. Okay? Hopefully that's clear. If not, we'll need to talk about that a bit more. But you need to kind of think about this and what it means. And when we get into calculation of air terms, we'll have to revisit this idea.